Well, hello and welcome to this exercise on the equation of a perpendicular line, which also takes in area of a triangle and graph sketching. And as usual, this is from a past iGCSE exam question and therefore suitable for GCSE high school and high school algebra, and also for upper school mathematics, upper secondary school maths, that is. Okay, now to begin with, we've got this grid here, which gives us limited numbers here. So we got on the x-axis, we got say minus 2, 0, and 2. And on the y-axis, we got minus 1, 0, and 3. So when we draw our graph, we must make sure that the points we choose for, say, 1, 2, or 1.5, whatever, the points we choose are reasonable points, are credible. For instance, if you said 1 is up there, that would not be right, will it? Just, that's not credible enough. Anyway, moving on. He says, sketch the graphs of the following lines. And the first one is y is equal to x plus 1. And the next one is y is equal to 2 minus x over 3. Okay, now for the first one, if x is 0, so we're looking at the y-axis or the line of y, x is equal to 0. When x is 0, y is 1. So we expect our point to be about there. Right. Similarly, on the x-axis where y is 0, when y is 0, x is minus 1. So we expect our point to be about there. Okay. And now we join both points to give us the line y is equal to x plus 1. Similarly, for y is equal to 2 minus x over 3, if x is 0, we're now looking at the the y-axis. When x is 0, y is 2. So we expect our 2 to be somewhere there. Okay. Now, I can say, as for the line for y is equal to x plus 1, if y is 0, look at the x-axis. If y is 0, then x is 6. But we are limited, you see, we stop at 2 here. So we have to do something else. I know it's easier to do y is 0. Right, if x is 2, so we expect our point to be somewhere on this line there. Line of x is 2 is equal to 2 there. When x is 2, y is equal to 2 minus 2 over 3, which means that y is equal to 1 and a third. So our point will be about there. Now, if we now join both points, we have the line for y is equal to 2 minus x over 3. Now, both lines meet at the point I as the point of intersection. Okay, right. And part B then says, find the coordinates of the point of intersection I of the two lines in part A. So we want to find the coordinates at this point here. So at the point of intersection, the x coordinates will be the same for both lines. So with the y coordinates. So we then say x plus 1 is equal to 2 minus x over 3. If we then multiply every term by 3, we end up with 3x plus 3 is equal to 6 minus x. And when we simplify, we end up with 4x is equal to 3. And if we then divide both sides by 4, we end up with x is equal to 3 over 4. Right. Now, if we then substitute x equal to 3 over 4 into the equation y is equal to x plus 1, we end up with y is equal to 3 over 4 plus 1. So y is equal to 1 3/4. So at the point of intersection, the coordinates then become 3/4 and 1 3/4. You can write it as 0.75 and 1.75. It doesn't matter. Okay, moving on. It says, find the area of the triangle enclosed by the lines y is equal to x plus 1. This one. The line y is equal to 2 minus x over 3. This one. And y is equal to 0, which is the y-axis. This is the line of y is equal to 0 there. Sorry, the x equal to 0. This is the x-axis. The line of x equal to 0 is this one here. Now we know that this point here, this point is the point 0, 1. We also know that this point is the point 0, 2. So the value of the length of this line here between the 2 points on the y-axis is just 1 unit there. So that's 1 unit there. We also know that this point here is 3/4. The x value is 3/4. So the value of the perpendicular line from the point I to the y-axis is 3/4. So the height of this triangle is 3/4. So the area then becomes 3/4 times the base times a half. That gives us the area of this triangle, and that's the value of 3/8 units squared. Hope that makes sense. Now for part D, it says find the equation of the line which passes through I and is perpendicular to the line y is equal to x plus 1. So we're looking for the equation of this line here, which is supposed to be perpendicular to the line y is equal to x plus 1. Okay. Right. We know that the gradient of the line y is equal to x plus 1 is 1. If we now assume that the gradient of the line, the blue dotted line, if we assume that the gradient is m, we know that the product of the gradients of two lines perpendicular to each other, the product is -1. So if we do m times 1, that gives us -1. That means that the gradient of at m is equal to -1. So the gradient of the line perpendicular to y is equal to x plus 1 in this case is -1. Now to find the gradient, we use the rise and the run method, and the rise in this case is y minus 1.75 and the run is x minus 0.75, and that gives us -1. If we then cross multiply, we end up y minus 1.75 is equal to -1 times x minus 0.75. If you then open out the brackets, we have that minus x plus 0.75 on the right hand side, and we got on the left hand side y minus 1.75. So y minus 1.75 is equal to minus x plus 0.75, and when we simplify it further, we end up with the equation of the dotted line, which is perpendicular to the line y is equal to x plus 1, is y is equal to 2.5 minus x. Now I hope all that made some sense, and please subscribe. Thank you for watching, and hopefully see you again sometime. Bye bye.